Hi, this is Jeremy Comel, CEO of Innovative Omics and research faculty at Yale University, working closely with Crystal Pollitt's lab. And today we're going to talk about ion mobility and version 2 of our FluoroMatch IM Mobility software, which may also be the same tutorial for any lipid match or polymatch updates if you're watching this. So first I want to go over the inputs and the final outputs. So you should have at least 2 files in your folder. A feature table with 4D peak picking, for example using the Agilent peak picking software, and an mzML file that will be used to generate EICs for retention time and drift time, as well as MS1 spectra. Now, to generate the mzML, you can open up msconvert, which comes with the software. If you want to use the version here, you can click these versions, or you can download msconvert at ProteoWizard. Now, you would open up msconvert, and here are the settings. So first you'd browse and find your .d file. Note that your .d file should be an IM mobility file with MS1 only for this purposes. All ions may work as well. So let's grab a file. The other thing, then you'll click add. The other thing you'll want to know about this file is that it should be demultiplexed if it's multiplex, or just don't use multiplexing. Then you want the output format to be mzML, a 64-bit export. Don't use zlib compression necessarily. I haven't tried all the parameters, I just know that these parameters work, so there may be better parameters. So please check the manual in case there's an update on the parameters for msconvert. And then as far as parameters, you would go to peak picking first. 1, threshold, absolute 100 in the case of the 6560. Default array length 2 dash and MS level 1, 1. You get the default array length and the MS level by going to subset, number of data points 2, and then MS levels you would put 1, 1 over here, and you'd click add. Make sure that these are in the correct order. You can move them around after you add them so that they match this screen. The other thing that you'll want to do is you'll want to do the threshold peak filter, and that you find over here. Make sure instead of count, it's absolute intensity, most intense, and then 100. And then you would click start. So that will be the mzML file in here and the feature table. Note that none of these files will exist, but these are the 5 files that should be generated once you run the software. So you should get a neg-ID'd fin, RT-EICs, drift time EICs, MS1s, and P formulas over here if you run the software correctly. So I'm going to delete these. Now, oops. Let's make sure to close this file. Alright, so now we have our 2 inputs. Make sure to have target in the mzML's name, and make sure that it ends in underscore negative, or just neg, N-E-G, just like you see here. So put underscore target, underscore neg in your file name, plus whatever naming conventions you want. And then similarly for your teacher table, put _neg. If it's a positive mode data file, which we haven't tested as well, but should work as well, just put _pos and _pos here. Now, if you go into the software, there are multiple different folders. So you can see here's where you'd find MS Convert. Here's where you'd find R to run. So let's open up R. So you'd go to R 4.4, bin, x64, and then open up the R GUI. If you use this version of R, it just makes sure that you don't have any package dependency issues because we've already downloaded all the necessary packages for you to use. So you'll double click that version of R, open it up, and then you're going to paste the script into here. So let's go into FluoroMatch again, and you'll see this FluoroMatch IM.R script. So you want to open that up. If you have RStudio, it will open up automatically into RStudio. Otherwise, you can open with, for example, Visual Studio Code, Notepad, anything you want. So let's open that up. Double clicking. And here you'll have your script. This video tutorial has been updated as of 11/28/2025. So let's update that for your code. But you don't have to change any of this. I'm just showing you where we're at. So now I'm going to highlight the entire code by pressing Control A, Control C, and then I'm going to run it in our R console that we opened up. So once you run the code, you can allow it to run. You will now get this dialog box. And this dialog box, you start from the top and then move down. Note you may have to drag it to find the run button down here, as it is very long. You can also change your display settings if you can't get to the run function there. So select your input file. Your input file is going to be that table that was generated from 4D picking. And then you're also going to upload, and note that that 4D picking file should have the mzML file in the same folder. And that's how it knows where to find the mzML file. So that folder that you uploaded your peak table should only also have the mzML file or files. Now, as far as choosing a library, you're going to go into the software. So if you navigate to FluoroMatch IM via version 2 or whatever version is the latest one you're using, and you can see the scripts and libs folder, there's library. So the 2025 is the most updated library as of this recording. So use the most updated library. And then you'd also choose a repeating units file. Note in this repeating units file, if you wanted to change the CF2 repeating unit to something else, you could change it here. But we recommend keeping it the same because you will need to change some of the later on visualizer and be a power user to do that. There's some things you have to modify later on. Now, there's some columns that it asks you for in your feature table. So we didn't mention this, but for your deconvoluted 4D peak picked table that you're using, it needs to have some necessary columns. That's a mass column, a retention time column, a CCS column, a drift time column, a row ID column, and an abundance column. Those are the necessary columns. We can generate some of those on the fly if we need to. So if you open up the table, now we can see all of those columns. So you can see that the ID column is in column 1, retention time would be column 2, drift time 3, CCS 4, MZ 5. So if we look back at our settings, we want to change these. So the MZ, or the mass column, is going to be 5. The CCS should be 4, retention time 2, drift time 3, as we discussed before. As you can see, the abundance is after the mass discharge 5, so that's 6. So you want to match these columns up. Right now, the defaults are matched to this file, but if there is any differences in the column numbers, you'd want to change them here. Note that for the ID column, it's going to be numeric, and if your software doesn't produce an ID column, just make one in Excel. Go type in 1, 2 under row 2 and 3, and then just click the drag down button to drag down across your entire table, inserting this row so that you have an ID column. So you can just add them. Also, if you don't have an abundance column, you can make an abundance column and just put 1 for the abundances. But you need to have an abundance column for it to work, but you can make a fake one. For the abundance column, note that the way it's used is it assumes that this is the max abundance. So let's say you have a bunch of samples over here, and you don't have this column, or it's not the maximum abundance across all these samples. You can change that by making a new column and then taking the max across your samples and dragging down, and then creating that max abundance column. So this can be a column that you make as well. Any other columns that you see here are extras. Any other columns are fine. They'll be carried over through the software, so in the final results, you'll be able to see all this information aligned with the annotation. Note that you should always start in row 2 with your data, so you should only have one single header in this table. Now, same thing for the library columns. You're going to want to match your library columns to this input parameters. If you're using the default libraries that come with FluoroMatch IM, which would be in here, the 2025 library is the one that the columns are set to, then the columns should already be set up for you in the right order, so you don't have to change these at all. Note here, for example, the name column is in column 1, and then as we see here, the name column is in column 1. So on and so forth, if you want to look through your library and match these. But again, if you're using the default latest CCS library, you don't have to change these column orders. And even if you add to this library, as long as you're adding using the same table and not changing the columns, then this should stay the same, so you'll never have to modify this. Row start should always be 2, as we discussed in your feature table. And then we'll add flagging. Always click flagging, that's fine. It's not going to remove anything, so you want flagging done. Then this is your mass window in Dalton, so plus or minus 0.005 Daltons, for example, or plus or minus 5 ppm. If you're using the Agilent 6560, usually you'll get plus or minus 5 ppm match tolerance. But if your mass accuracy is off on your instrument or just wider, you can change and modify that parameter here. Again, on the 6560 with good calibration, usually your CCS window is plus or minus 1% or a 2% window error. Note that if your peaks are saturated, then that can go off to up to 10% or plus or minus 5% or 6% or even more. And so you may have to modify this window to capture those identifications for saturated peaks. Now you also have these 2 parameters over here. These 2 parameters are the predicted CCS error from the database and the experimental CCS error. In this current library, there's no experimental CCS, but there are predicted CCS. And so for that, I went to the literature and they said 90% of the CCS values that were predicted and their validation set had a plus or minus 5% error or less. And so I put a 10% error here. So you don't have to change this for the library, but you can. And so what it will do is when it's matching the CCS to the predicted libraries, it's going to add a plus or minus 5% error to this plus or minus 1. So it's going to be a plus or minus 6% error now when it's searching against the database. Then you have your mass defect upper and lower flags. These aren't too important because you can do mass defect filtering later, but these are the defaults for flagging molecules that might fall out of their mass defect, and your polarity. So after you've hit all your settings, then you can click Run, and the software will run, making sure you've uploaded those folders. You also don't want any of your files open, especially if you've modified them. That can cause some issues as well in the software, so make sure you have all these files closed. And now the software is going to run. As you can see here. Now, as it runs, if we look back at our LMN, now you can see that the files start to get generated here. And then once the software is done, it will print a print statement saying software is complete. Congratulations. So for example, here we've linked R to RStudio, which is another option if you want to link it to the correct version of R. And so you'll see when it's finished running, you'll get this print statement if there's no errors. Sometimes it runs past errors too, so you want to scroll up and get errors. Another way to know that it's complete is that you will have all those files that we mentioned earlier. So you should get all of these 5 files plus your inputs will stay in your folder. And that's how you know that it's completed. So with that, I'd like to close this tutorial. We are currently collaborating with Shahar Mohsen, and we are doing IM ability trainings, both on the acquisition platform and the instruments, as well as on the software. So if you have IM ability and you want to be a power user and take your lab to the next level, please reach out to us at innovative-omics.com, which will also be in the chat. So looking forward to talking to you. Please reach out as well. There's my contact there. If you have any very cool results, we can add that as news on our website. I'm always just interested in how people are applying these software.